friends, I'm Grishma and you're watching my channel G Tutorial. In today's class, we can learn about how to find the units digit of an exponential and also the last two digits of an exponential. If you like my video, please subscribe to my channel for getting more RRB JE related videos. Now let us get to our portion. First, let us study about how to find the units digit of an exponential. We are categorizing the digits into three cases, and in the first case let us learn about the numbers 0, 1, 5, 6. The last digits of the exponential of a number ending with 0, 1, 5, 6, etc. Then as exponential will also have the same digits as 0, 1, 5, 6. For example, if you are taking 55 raised to 75. This is exponential of 55. 55 raised to 75. This number is ending with 5. So its exponential will also end with 5. Last digit or unit place is 5. Next is 1. If a number is ending with 1, then its last digit will also be 1. If the number is ending with 5, we have considered the case 0. If the number is ending with 0, then also the last digit will be 0. If the number is ending with 6, then the last digit will be 6. This is the case of numbers 0, 1, 5 and 6. Next, let us study the case of 4 and 9. In both cases, if the number is even, if you are taking 4, if the power is odd, then the last digit will be 4 itself. Similar is the case with 9. If the power is odd, then the last digit will be 9. But if the power is even, then the last digit will be, what is 4 square? 4 square is 16. Last digit is 6. So the last digit when the power is even is 6. Similarly, in the case of 9, if the power is even, then the last digit is, what is 9 square? 9 square is 81. Last digit is 1. So in this case also, the last digit is 1. So let us see some examples to understand this very clearly. 524 raised to 621. What is this power? This power is even or odd? 621 is an odd number. So the last digit will be what? 4 itself. Since the power is 621 is odd, so since the power is odd, the last digit will be 4 itself. Raised to 76. 76 is an even number, so the last digit will be 6. Next question. We can consider the case of 9. 979 raised to 729. The power 729 is odd, so the ending digit will be 9 itself. 9 raised 920 raised to here 242 is an even number, that is the power is even, so the ending digit will be 1. I think you are clear with the 4 and 9. Next, let us see some other cases. Next, let us see the cases of 2, 3 and 7 and 8. They all follow the same method. First, let us see the case of 2. For finding the units digit of a number ending with 2, its exponential will be, we have to follow this table. Power and units digit. If 2 raised to 1, what is 2 raised to 1? 2 raised to 1 is 2. 2 square is 4. The ending digit is 4. 2 cube is 8. 2 raised to 4 is 16. So the units digit is 6. Next is 2 raised to 5. 2 raised to 5 is 32. Ending with 2. 2 raised to 6 is 64. So, after 4, the cycle repeats. So, the cyclicity is equal to 4. So, for finding the units digit of an exponential of a number ending in 2, that is 242 raised to 76. What we have to do is, we have to take, this is a number ending in 2 and we have to find the exponential of that number. We have to take this exponential. We have to divide that exponential by its cyclicity. That is 76 by 4. 76 by 4 is, we have to take the remainder of that. Remainder is 0. If remainder is 0, we have to take it as 2 raised to 4. What is the ending digit of 2 raised to 4? 6. So the answer is 6. If you are considering another example, 72 raised to 35. What we have to do, we have to divide this exponential by cyclicity. Cyclicity is 4. That is 35 by 4. What is 35 by 4? Remainder. We have to find the remainder. 35 by 4 is 8 4s are 32. Remainder is 3. The remainder in this case is 3. So 2 raised to 3. The ending digit of 2 raised to 3 is the answer for this question. Ending digit of 2 raised to 3 is 8. So the answer of this question is 8. The ending digit of 72 raised to 35 is 8. Next example. 42 raised to 17. So what we have to do? We have to divide the exponential by 4, which is the cyclicity. 17 by 4 is 4 into 4 is 16. Remainder. We have to find the remainder. Remainder is 1. So the ending digit of 2 raised to 1 gives the answer of ending digit of 42 raised to 70. 2 raised to 1 is 2. So the units digit of this number 42 raised to 17 is 2. Now I think you are clear with the case of 2. Next let us see the case of 3. For 3 also we have to follow this step. 3 raised to 1 is 3, 3 square is 9, 3 cube is 27. We need only just the units digit, so 7. 3 raised to 4 is 81, units digit is 1. According to this table, we are finding the answer for the exponential, unit digits of the exponential. Now let us take some examples. Here also the cyclicity is 4. After 3 raised to 4, 3 raised to 5. The ending digit of 3 raised to 5 is 3. 3 raised to 6 is 9. Like that. So after this it repeats. So we just need to study only this much. Next is 73 raised to 49. Okay. So what we have to do is we have to divide for the exponential by its cyclicity. Cyclicity of 3 is 4. The cyclicity of all these is 4. All 2, 3, 7 and 8 is 4. So you just need to divide this exponential by 4. 49 by 4 remainder is what? 1 is remainder. So 3 raised to 1, the ending digit of 3 raised to 1 is the answer for this question. Answer is 3. Next is 749. So raised to 23. 23 by 4 is remainder is 3. So 3 raised to 3 gives the answer for this question. 3 raised to 3 ending digit is 7. So the answer is 7. Next question. We have to divide 27 by 4. The remainder is 3. 4 6 are 24. Remainder is 3. So the ending digit of 3 raised to 3 gives the answer. 3 raised to 3 ending digit is 7. Next is 28. 28 by 4 is 0. So the answer will be 3 raised to 4. 3 raised to 4 ending digit is 1. So the answer is 1. I think you are clear with 3 also. Next. The case of 7 and 8 is also similar to 2 and 3. We have to study this table. The power 7 raised to 1 is 7. 7 square is 49. Its unit digit is 9. 7 cube is 512. Unit digit is 3. 7 raised to 4 is 2401. Unit digit is 1. Similarly, in the case of 8 also, the power of 8 raised to 1 is 8. 8 square is 64. So unit digit is 4. 8 raised to 3 is 512. Unit digit is 2. And 8 raised to 6 is 4096. Unit digit is 6. So we have obtained these questions. Next, let us do some examples. The cyclicity is again 4 in both cases. So let us do some examples to understand this clearly. 67 raised to 93. So what we have to do? We have to divide the exponential by 4. 93 divided by 4 and find the remainder. One is the remainder. So the ending digit of this is just 7 raised to 1, which is 7. Next is we have to divide. It will be 39. We have to divide 39 exponential by 4. 39 by 4 remainder is what? 39 by 4. 36. 4 9s are 36. Remainder is 3. So 7 raised to 3 gives the answer of this question. Remainder 39 divided by exponential divided by 4 gives 3 as remainder. So 7 raised to 3 gives the answer of this question. 7 raised to 3 ending digit is 3. So the ending digit of this number is also 3. Next, let us do some examples of 8. We have to divide the exponential by the cyclicity. 28 by 4. 28 by 4 is 0. So 8 raised to 4 gives the answer. So 6 is the ending digit of this question. Next is 11. What is the ending? 11 by 4. 3 is the remainder. So 8 raised to 3. 8 cube is 2 is the unit digit of this number. What is this? Ending digit of 48. We have to divide the exponential by 4. 729 by 4. Remainder is 1. So 8 raised to 1 gives answer 8. Okay. I think you are clear with how to find the last digit of our units digit of a given exponential. Now let us do some problems based on what we have studied till now. First question. Find the units digit in the expression. This is the expression 55 raised to 725 plus 73 raised to 5810 plus 22 raised to 853. So let us consider each of these terms. First term is 55 raised to 725. The ending digit of this number is 5. So we have seen that 5 raised to an exponential, the ending digit will also be 5. 0, 1, 5 and 6 have unit digit same as the exponential term, and the unit digit of the number will be same. So the answer is 5. Next is 73 raised to 5810. So 3 raised to something. 3 raised to something means we have to divide the exponential by 4. So 5810 divided by 4, the remainder is 2. We have to take this remainder. So 3 square, the ending digit of 3 square will be the answer of this term. Next is 22 raised to 853. Again 2 raised to something. The same method. That is, we have to divide the exponential by cyclicity, that is 4. 853 by 4, remainder is 1. So, the ending digit of this is 2 raised to that remainder, 2 raised to 1. So, 5 plus 3 square is 9 plus 2. 2 raised to 1 is 2. 5 plus 60. So the ending digit is 6. Next question. 657 raised to 85 minus 158 raised to 37. 7 raised to something, 8 raised to something. This is also, we have to follow the same case. That is, divide the power or exponential by 4. 85 by 4, remainder will be 1. So 7 raised to 1 minus 8 also follows the same rule. We have to divide 37 by 4, remainder is 1. So 8 raised to 1. 7 raised to 1 is 7 and 8 raised to 1 is 8. So the answer is minus 1. We just need the unit digit. So answer is 1. Now we have studied how to find the unit digits of a given expression. Next, let us see how to find the last 2 digits of a given exponential. Now let us learn how to find the last 2 digits of an exponential of a number ending in 1. So what we are finding is, we know that if a number is ending in 1, then its exponential, the unit digit of the exponential is also ending in 1. The next digit is found by, we have to multiply 2 into 2. So 2 into 2 is 4. The last 2 digit is 41. Next question. The last digit is 1. Next digit is 8 into 8. 8 into 8 is 64. So 41 is the ending digit. Next. Last digit is 1. Next is 4 into 4. 4 into 4 is 16. So 61 is the ending digit. If you are considering another example, 320. The last digit is 1. 9 2s are 18. So 81 is the last digit. I think you are clear with the case of 1. Now we can see the other cases. Let's see the cases of numbers ending in 3, 7 and 9. For that we have to study this table. The last 2 digits of number will be, if 3 raised to 1 is power of, if 3 raised to 1 is 3, 3 square is 9, 3 cube is 27 and 3 raised to 4 is 81. So, how we are doing to find the last 2 digits of the given exponential, 3 raised to 124. We have to divide 124 by 4. 124 by 4 is 4 3s are 12. 4 into 1. 31 into 4 is 124. So we are expressing 124 as 3 raised to 4 into 31. So it is equal to 3 raised to 4, the whole raised to 31. So what is 3 raised to 4? 3 raised to 4 is 81. 81 the whole raised to 31. Now what we are doing? If 1 is the ending digit, 1 is the ending digit of the answer also. Next we are doing 8 into 1. 8 into 1 is 8. So the ending digit is 81. Next question. 3 raised to 127. The ending digit will be, first we have to take 127 divided by 4. So here we have done the case of 124. So it is not needed. Let us take it from here. So 3 raised to 127 can be expressed as 4 into 31. 4 into 31 is 124. So 3 raised to 127 is 3 raised to 124 plus 3. 124 can be expressed as 4 into 31 plus 3. That is equal to 3 raised to 4 into 31 into 3 raised to 3. Or 3 raised to 4, the whole raised to 31 into 3 raised to 3. What is 3 raised to 4? 3 raised to 4 is 81. So 81 raised to 31 into, what is 3 cube? 3 cube is 27. So what is the ending digit of 81 raised to 31? Ending digit of number ending in 1 is 1. 8 into 1 is 8. So 81 into 27. The ending, the last 2 digits of this product gives the ending digit of 3 raised to 127. What is 81 into 27? 1 7 is 7. 8, 5. 21. So the ending digit is 87. Okay. Now let us see the case of 7. 7 also follows a table. If the power of 7 is 1, Then the last two digit is 7. The power is 2. 7 square is 49. 7 cube is 343. So 43 is the last two digit. 7 raised to 4 is 2401. So the last two digit is 0. Now let us do some examples. So 7 raised to 45. The last two digits of 7 raised to 45. What we have to do? We have to express 45 in terms of 4. 45 by 4. What is 45 by 4? 45 by 4 is 4 11s are 45. Remain this 1. So 45 can be expressed as 7 raised to 44 plus 1, or 7 raised to 4 into 11 plus 4. That is 7 raised to 4 the whole raised to 11 into 7 raised to 1. That is 7 raised to 4 is last two digits is 0 1. So 0 1 raised to 11 into 7 raised to 1 is 7. Now what we have to do? The last digit of 1 1. 0 into 1 is 0. So 0 7 into 7. The last two digits is 1 into 7 is 7 0. So the last two digits is 0 7. Next is 7 raised to 2010. What we have to do? We have to express 2010 in terms of 4. So dividing by 4. 4 5s are 20. 0 5 0. 10 2 times 8 remainder 2. So we can express this as 7 raised to 2010 is equal to 7 raised to 4 into 502 plus 2. That is 7 raised to 4 the whole raised to 502 into 7 square. That is 7 square is 49. 7 raised to 4. 7 raised to 4 is what? 0 1. So 0 1 raised to 502. So ending digit is 1. 0 into 2 is 0. 0 into 0 1 into 49. So the ending digit is 49. Okay. Now let us see the case of 9. The case of 9 follows this table. Power of 9 is 1. The last digit is 0 9. And power is 9 square. The last digit is 81. So if the question is 9 raised to 124, what we have to do? We have to divide 125 by its cyclicity. That is 2. So we can express 124 as half of 124 is 62. So 2 into 62. That is 9 square the whole raised to 62. 9 square last two digits is 81. So 81 raised to 62. If a number is ending in 1, the last digit will be 1. Next is 8 into 2. 8 into 2 is 16. So 61 is the ending digit. Ending last two digits of 9 raised to 124. Next question. 9 raised to 23. So 23 can be expressed as 2 into 11. 22 plus 1. So 9 square is 81. 81 raised to 11 into 9 raised to 1. That is the ending digit of 9 raised to 1 is 0 9 or 9. And 81 raised to this is ending digit is 1. 8 into 1 is 8. So 81 into 9. 81 into 9 is 1 9s are 9. 8 9s are 72. So 29 is the ending digit of this number. Okay. We have studied the case of 3, 7 and 9. Let us study the case of rest of the numbers in the next class. If you have any doubt, you can comment below. Thank you.